Alrighty, so now we're going to look at the processes that have created Motutata Island. So that is the stack that stands freely away from the headland, Otakamedo Point, just here. Alright, so this is the feature that we're going to be talking about, and we're going to talk about how the processes that created that. So I'm hoping that you've watched this one after you've watched the processes that created the caves, because that is essentially exactly how Motutata Island was created. All right, so we have our climate, the transfer of energy from the wind into the waves. We've got our wave pounding, so we've got the transfer of energy from the waves and into the rocks, and then we've got all of our wave processes, primarily our hydraulic action and our attrition. So those are still the primary key processes that have happened to create the stack, Motutata Island. So here it is here. Apologies for the quality of this. This is a photo. I don't have a scanner, so apologies. So here we go. We can see that wave refraction, bending, and the energy attacking the headland. You can see that the caves are forming. So as those caves keep forming through wave pounding, attrition, abrasion, what actually happens is an arch is formed, because if you have a look again at our map, we have our caves on either side of the headland. We've got that wave refraction coming and hitting in, and so that energy is just going to constantly keep bending around that headland, and it's going to constantly be transferring into the rocks, into that Manicarbreccia conglomerate. And so as it does, and as it keeps going, it's just going to go further and further and further inland until it meets and creates an arch. So that is the second um, diagram here. So we've got that arch. Alrighty, but then the next step after that is that we're still going to have those wave processes happening. We're still going to have our attrition. We're still going to have our hydraulic action. But now we step back a bit and we head into a bit of weathering. So we get to see those subaerial processes. So primarily that process of wetting and drying. So as the sea spray and as the rocks get wet and then they dry and then they get wet and then they dry, that actually weakens the structure of the rock. All right, the salt crystals are left behind. They actually embed themselves into the rock in those areas of weakness. But when they dry, they expand. And what we've realized is that when things expand, it actually weakens the structure of the rock and helps it erode quicker. So we've got that happening. Once that keeps happening, that arch is getting wider and wider and wider, and the top of that structure, so up here, is actually getting really heavy, and it's very hard for it to be to support all of that transfer of energy from the waves and from the wind. So it's becoming an unstable structure. Not to mention, we've also got the weathering of the plants. All right, so we've got the plants' roots growing down and weakening the structure from the top, and burrowing animals, from where they are trying to the roots are trying to go down to get more moisture as they do as plants grow, weakening the structure even further. So eventually, over time, what happens is it gets so heavy it collapses, and we have what we see now is the stack, Motutata Island. Key point here is Motutata Island actually became an independent stack away from the headland 20,000 years ago. So just a reminder of those processes that created the stack. We have wind, so we've got climate with the wind, then we have the wave energy, the wave pounding, attrition, hydraulic action. Then we've got the weathering. We've got those subaerial processes, wetting and drying. All weakens the structure of that rock to give us our stack. So if you haven't done so previously, watch the caves, then rewatch this one.